Assalamualaikum. My name is Muhammad Azinuddin bin Abdul Kamal. Today I will be presenting antibiofilm activity of benzoic acid against Salmonella typhimurium. Salmonella typhimurium can cause typhoid fever, which result in morbidity and mortality towards human and animals. Salmonella typhimurium is transmitted by contaminated food or water. According to World Health Organization, or commonly known as WHO, typhoid fever causes sickness of 11 to 20 million people and deaths of 128,000 to 161,000 individuals annually. In this study, we can prevent the death-causing illness by using antimicrobial activity of benzoic acid on Salmonella typhimurium, as benzoic acid does not have any harmful side effect on human application and does not damage to the ecosystem if exposed to the environment. The objective of this study is to evaluate the antibiofilm activity of benzoic acid against Salmonella typhimurium and determine the effect of benzoic acid antibiofilm properties. The method used in this study is preparation and confirmation test on Salmonella typhimurium, which consists of gram staining of Salmonella typhimurium, UV vis spectrophotometer, pellicle assay, and catalase assay. Next is biofilm formation in 96 soil microplate. 100 microliter of inoculum was seeded into 96 soil microplate along with 100 microliter of benzoic acid, which then incubated at 37 degrees Celsius for 24, 48, and 72 hours. While for biofilm formation in 6-well plate, 2 ml of inoculum was seeded into 6-well plates along with 2 ml of benzoic acid, which then incubated at 37 degrees Celsius for 24, 48, and 72 hours. Both 96-well microplate and 6-well plate were air-dried after incubation, which then was stained for 15 minutes with crystal violet. Biofilm in 96-well plate was suspended in absolute ethanol as in initiation of biofilm biomass assay. At the absorbance of 600 nanometer, optical density was obtained using microplate reader. Biofilm in 6-well plate were observed under light microscopy to determine the surface coverage of biofilm. ImageJ software were used to analyze the coverage of the biofilm. The image is the result of pellicle assay. We can see there are no biofilm formed at 6 hours, but in 12 hours, we can see a light mark of biofilm in the test tube, and in 18 hours, we can see a few dark blue spots in the test tube. UV spectrophotometer shows a value of 0.934. Indicates there is a significant amount of bacterial growth in the culture. Catalase test shows there are bubbles when the diluted inoculum was dropped with hydrogen peroxide, indicating the inoculum is Salmonella typhimurium. Lastly, gram staining shows like a rod-shaped bacteria, indicating that Salmonella typhimurium is present. The images shows the biofilm biomass assay by using 96-well microplate, where the concentration of benzoic acid, which is 100%, 50%, 25%, 12.5%, 6.25%, and negative controls are from left to right on x-axis, and the percentage of biofilm inhibition is on the y-axis. All of the graph indicates a downtrend for percentage of biofilm inhibition as the concentration of benzoic acid decreases. The highest percentage of biofilm inhibition from the graph of 24 hours is 36%, followed by 35%, 14%, 3%, 2%, and lastly 0%. Meanwhile, the highest percentage of biofilm inhibition from the graph of 48 hours is 61%, followed by 45%, 39%, 27%, 24%, and 0%. Lastly, the highest percentage of biofilm inhibition from the graph of 72 hours is 88%, followed by 86%, 52%, 43%, 30%, and 0%. The images shows the result of biofilm surface coverage by using 6-well plate, where the biofilms were observed under light microscope, which then used ImageJ software to analyze the surface coverage. We can see that both images shows the biofilm covers the surface in the negative control, which then slowly eradicated and become less abundant as the concentration of benzoic acid increases. In conclusion, the study to determine the biofilm activity of benzoic acid against Salmonella typhimurium and to determine the effect of benzoic acid against biochemical composition of Salmonella typhimurium was successfully achieved. The higher the percentage of benzoic acid, the higher the percentage of biofilm inhibition, and it was proven that benzoic acid is able to inhibit up to 88% of biofilm formation by Salmonella typhimurium. In the future, additional investigation might be needed to improve the antibiofilm properties of benzoic acid against microbial biofilm, which can contribute to improve infection control and produce new antibiofilm treatments.